Hello, my name is Matthew Girgis,
And my name is Madison Darr.
and our project is the redesign of a solar automatic license plate reader trailer. Automatic license plate readers are used across the nation by our law enforcement to run plates of vehicles throughout databases of numbers with prior violations. Sometimes these are mounted on infrastructure like traffic lights, patrol vehicles, or sometimes on mobile trailers like at border checks. The goal of this project is to redesign a solar-powered trailer that was constructed to replace the gas-powered generator systems that are currently in service.
The image here shows the first iteration of this trailer, which only had 6 panels, while the second iteration will have 8 panels. The first trailer was also built from only a flatbed trailer with wooden boxes. These wooden boxes were not only getting worn down by the winter rains and the extreme heat in the summer, but they were also suffocating the components in the batteries.
In completing this redesign, we had to select a trailer, design external mounts for the panels, redesign the trailer to compensate for seasonal and thermal issues, and to document the build for future production. Another key design parameter was the necessity that the trailer be considered mobile by Caltrans, meaning the trailer should be easily disassembled for transport.
So to begin the design process, we knew that we were going to acquire a new trailer, but had to decide what kind. 3 options for the types of trailers were enclosed, another flatbed trailer, or a custom trailer that could have a wedge design for easy angling of the panels. Ultimately, we decided that an enclosed trailer would be the best option for our project because it would provide the sturdiest support for the panels, would give us room for expanding components inside, and was the most sensible in terms of reproducibility for alterations and cost.
After these considerations, we procured a 6-foot by 12-foot enclosed trailer, and the next step for us was to build the external mounting supports for the solar panels. We made sure to pay attention to the arrangement we were going to lay the panels out in, and began using the same off-the-shelf part superstrut steel bars the first prototype had. We knew that we wanted to make sure the panels were completely stable as well as ensure the configuration is not too complicated, so it would require only 2 people to disassemble. Also, we wanted to keep the profile or the overall height to a minimum in order to draw the least amount of attention. So we kept this as another parameter in the back of our minds. The original prototype had all 8 panels laid out in a line, which totaled 27 feet, 15 feet longer than the trailer we selected. This configuration provided a really low profile from the ground, which was beneficial to draw less attention to the trailer. But we wanted to move away from the 1x8 arrangement of the panels because we did not want to rely on any external supports down the length of the panels.
Another option we considered was having 2 separate rows of panels, one mounted on the roof of the trailer and one mounted on the side of the trailer. Although this positioning created a very tall profile, we considered this for a while because we saw using the roof to support 4 panels as an advantage, where we would only have to be concerned about the weight of the remaining 4 panels mounted on the side. Unfortunately, once we procured the trailer, we discovered how thin and unsound the roof was and knew it would be necessary for external framing to be built regardless of being on the roof or on the side. After realizing we should not use the roof as a support, we decided the best option would be an external framework of off-the-shelf superstrut steel bars that we would bolt into the steel framework of the trailer. Then we would have a grid set up with the panels in a 2-row, 4-column configuration, which allows the grid to fit within the length of the trailer with minimum overhang. This arrangement requires that there are legs at the bottom of the panels to support them, but this actually turned out to be an advantage we will discuss later. So this last configuration is the design we went forward with, and this is a picture of our work during the construction of reinforcing the superstruts on the trailer and setting up the arrangement of the panels. The photo on the left shows an underside or interior view of the panels to highlight how they are attached. The red lines in each photo indicate the same crossbar where the panels will be mounted to the trailer.
Knowing that the 32 battery storage pack would be an immense burden on the thin floor, a total of 2,400 pounds of batteries, we built a secondary floor with an extra frame of 2x4 planks and a 3/4-inch plywood, and did a basic finite element analysis to ensure that the batteries would not cause too much warping to the wood. Given the area of the secondary floor, the batteries would provide 0.31 pounds of force per square inch. This image describes the resulting displacement of the wood from the finite element analysis. The red color indicates the max deformation, which is 0.00004 inches. So given these results, we deem the secondary floor structurally sound enough to support the batteries without concern of warping.
As was mentioned earlier, the overheating of the batteries and electrical components was a serious concern of the first prototype. Although the components never failed due to overheating, running electronics at high temperatures can damage them even if they continue to function for a while. To remedy this, we built a wall in the trailer to separate the batteries and electrical components and calculated how much air is recommended to be circulated for that square footage. This image shows the electrical compartment in the middle of installation. Another benefit of having a larger enclosed trailer is the availability of mounting space for the electrical components to ensure they are maintaining the manufacturer recommended distances from walls and other components.
These are top views of the trailer to show the two compartments separated by the wall shown in the previous chart. Highlighted on the left is the battery compartment, which requires 38.5 cubic feet per minute of airflow, and the electrical compartment, highlighted on the right, requires 6.3 cubic feet per minute of airflow. The best weatherproof and remotely controlled trailer roof vent was the Max Fan Deluxe, which provides 900 cubic feet per minute, which is well over the recommended airflow for the areas, but has the capability to turn on when certain temperatures are reached, which helps maintain the autonomy of the trailer. To accompany the fans, intake vents will also be installed, 3 for the battery compartment and 1 for the electrical compartment. In addition, there will be multiple temperature gauges installed throughout the trailer that will help us monitor the interior temperatures and adjust the thermal management as necessary.
Since we were going through many different arrangements of the panels and considering different profile heights of the panels, we became aware that our modular design with the supporting lugs could also benefit us in adjusting the panels for the different seasons. Occasionally, during the winter months, the trailer in service lost power when the trailer was under cloud coverage for about 14 days in a row. Our solutions to this were to optimize the angles of the panels and add backup power. This chart shows the optimal angles that solar panels should be positioned at to ensure the maximum energy collection in Southern California. With our selected design for the solar panel mounting, the only adjustment needed to be made to change the angle of the panels is to exchange the support legs at the base. Although the trailer has only had trouble providing enough power during prolonged cloud coverage, this solution is a simple and incredibly cost-effective way to maximize the energy harnessed by the panels. The 3 images in the chart show a front view of the trailer and emphasize how the arrangement of the panels we selected allows for the most conservative profile of the trailer, along with enabling the panels to adjust to the sun during different seasons.
Although we are designing a self-sustaining solar-powered trailer, during the cloudy seasons and winter months, a backup power system is essential for powering the license plate reader when the solar panels are not a sufficient power supply. Since gas lines or electrical power is not easily accessible in most locations the trailers would be deployed, a portable generator that is powered by gas or propane was looked into. The backup generator must have a remote start and automatic start for when the storage in the batteries drop too low. There must be a fuel gauge on the generator in order to monitor as well, in order to know when the generator needs to be filled up. After much research and weighing of each of the advantages and disadvantages, propane showed to be the better decision. The advantages of gasoline is that it is cheaper and a more available source of fuel. It also provides more energy per cubic foot. Propane has its advantages in that it's a more eco-friendly gas, and it's considered as a clean burning fuel since it produces less pollutants than diesel and gasoline. Unlike gasoline and diesel, propane can last about 10 to 12 years in a given storage tank, since it does not degrade as easily. Specifically, it produces only half as much carbon monoxide as gasoline. Since propane tanks are equipped with safety valves, they're far less likely to spill than gasoline and diesel fuel, since their storage containers have no valves. Propane also doesn't have as much temperature-related problems compared to the gasoline and diesel. The disadvantages correlated with gasoline is that it's a very flammable liquid. The gasoline generators require more maintenance as the gas must be replaced at least every 6 months. The dirtier fuel also gives off more pollutants and does not last as long. The disadvantages correlated with propane include a more expensive fuel and generator cost. Propane also burns at a faster rate than gasoline, which requires a larger storage tank. Overall, the propane generator would be a better choice for our application.
One of the largest considerations in decision-making for the design and choice of the enclosed trailer were due to the need for reproducibility. Though we were tasked with redesigning a prototype trailer in order to provide a proof of concept prototype, the company desired a design that would showcase the ability of the trailer to be mass-produced in a reasonable time. One of the biggest factors was choosing a non-custom enclosed trailer. If we had chosen to design from a flatbed trailer, the custom work would be much more complicated and labor-intensive than beginning with an enclosed trailer.
The first iteration of this trailer is being used by a government agency that is otherwise dependent on gas-powered trailers, and they are using the first prototype as a proof of concept. The company is not currently turning a profit, and therefore the budget was not infinite, but was plentiful within reason. For example, with the purchase of the trailer, although a custom trailer would have required the least amount of self-customization, buying an enclosed trailer and customizing it ourselves helped reduce the cost. The materials purchased for the most recent prototype were bought individually at retail stores through the construction, but in the future trailers, most of the materials such as the superstrip beams and hardware will be bought in bulk in order to save money. In a lot of the design, we also could have had the work outsourced. But for the purposes of this being a single build of another prototype, the company was working with us to do the construction ourselves.
When beginning this project, many designs were being considered while waiting for the trailer to be purchased by the company, so we turned to 3D modeling via SolidWorks to help us continue our work. Being able to have a preliminary model of the trailer, the panels, the batteries, and the components allowed us to easily communicate our ideas to our remote partners and aided us in our decision-making. Along with using NX Nastran for finite element analysis, we also used MathCAD software to help us calculate heights of the trailer, angles of the panels, and the necessary venting. Using MathCAD was very advantageous because we were able to quickly adjust different parameters to match our designs that were changing often.
Looking to the future with this project, the company is continuing the manufacturing of this trailer, which will prove to be a simpler and more reliable prototype of the first iteration. We hope that this trailer will be an option for mass production to replace the costly gas-powered trailers currently in service. Thank you for listening.